This one's a nodal analysis. Also, you'll hear it called node voltage analysis. And this is my typical way of solving circuits, just because it's, just what I've always done. And here's how it works. You pick one node to be ground, and unless there's some reason not to, I usually pick the bottom, because that's usually the way the problem's set up. And then I may have done this problem before. Does it look familiar? It's not from your book, so yeah. So okay, well, let me just go ahead and do it. Okay, so there are actually 3 nodes here, but I'm not, well, 4, there's more. There's more nodes than I need to put in my equations. So anything that I don't have to put in my equations, I'm not going to, because the fewer variables I have, the better. My nice little calculator that I like to talk about so much will do a system of 3 equations and 3 unknowns. If I have more than 3, I have to get out my TI-84 or the computer. And so I'd like to keep it to under 3 if possible. So I have this node right here, but I don't have to give that a variable name, because if I call this the bottom branch ground, then this one has to be 30, because I've got my 30-volt voltage source. The positive side has to be 30 more than the negative side, so that has to be 30. I'm going to call this one V1 and this one V2. And I'm not going to do this one as a separate node just yet. I could, but that would make my life a little harder. So I'm going to come back and find this voltage difference after I solve the rest of the circuit. So I'm just going to treat this as one 8-ohm resistor. So I've got, this is 30, this is 4 ohms, this is 12 ohms. I called this V2, I called this V1, 1 ohm, and I'm going to treat this as 8 ohms. So this is KCL, so mesh was KVL, and nodal analysis is KCL. And what you do, or the way I recommend doing it, is sum up all currents leaving the node and set equal to 0. So remember, we said we can draw currents going however we want. And if they're actually going the other direction, then the sign will come out negative. And so that's why we can draw them all going out of the node, is it'll end up that some are positive and some are negative. But the sum of all of them, if we draw them all going out, then it has to be, the sum has to be equal to 0, because current going in has to equal current going out. And so if they're all going out, then that has to be 0. This means current going into a node, like a current source, is negative, and current going out is positive. So I'm adding up all the currents coming out of a node. That means if I have a current source that's going into a node, then I make that one negative. Write each current as the The voltage, you'll be working at a particular node. We write an equation for each node. So, probably should have written this first. So we'll write an equation for each node. And then as we write the currents for that node, we're going to write them as the voltage at that node minus the voltage at the node on the other side of the resistor over the resistance, because that's what current is. So it's the change in voltage. So I'm going to start by writing my equation for V1. So for V1, first of all, I've got a 4.5 amp current going into the node. That makes it negative. So that's just negative 4.5. Plus. Now all of the currents that I'm going to draw coming out of this are going to be plus, and it'll be V1 minus some other voltage. So the first one I'll do is the one going down this branch right here. This was ground, that's 0. So that one will be V1 minus 0 over 1 plus, then I have the one going to the right. That'll be V1 minus V2 over 8, and that equals 0. And that's all of the currents coming out of V1. And now I'll do the currents coming out of V2. So going this direction, I'll have V2 minus V1 over 8. Any current that goes between two nodes is going to show up twice in negative of each other in the different equations. And then I've got the one going down, so plus V2 minus 0 over 12, and then plus V2 minus 30 over 4 equals 0. And I don't like fractions, so I'll multiply through by the common denominator, which is 8. 4.5 times 8 is 36. So negative 36 plus 8V1 plus V1 minus V2 equals 0. And I'll multiply this bottom one through by 24. So I get 3V2 minus 3V1 plus 2V2 plus 6V2 minus 180 equals 0. So this first equation becomes 7V1 minus V2 equals 36. And the second equation becomes minus 3V1. 3 plus 2 is 5, plus 6 is 11, plus 11V2 equals 180. Let me see if by any chance those are right. I have no idea, because the problem was done differently. Yep, don't know. Alright, so now let me solve those. I do not want to do that one by hand, so I won't. So second system solve. The wrong calculator. Yep. Second system solve, and I have a 2 by 2. And it was 7 minus 1 equals 36. And negative 3 plus 11 equals 180. Solve. That doesn't look promising. So I have some mistake somewhere. Did anybody see where my mistake was? Okay, let me go back and look. Let's see. That's 8, 4.5, 12, 4, 30, minus 4.5, V1 over 1, V1 minus V2 over 8, V2 minus V1 over 8, V2 over 12, V2 minus 30 over 4. .5 times 8 is 32 plus 4 is negative 36 plus 8V1 plus V1 minus V2 times 24, 3V2 minus 3V1 plus 2V2 plus 6V2. 6 times 30 is negative 180. 8V1 plus V1 is 9V1 instead of 7. That looks better. So V1 is 6 and V2 is 18. Of course, in the real world, the voltages do not have to be nice whole numbers. So V1 is 6 and V2 is 18. Now we can use that information to help us get the answer to what the voltage drop is across here. So V1 was 6 and V2 was 18. That means we can get the current. Well, I'm going to use voltage division to find out what the voltage is right here in the middle. So we're going to use voltage division. So voltage division will tell me the voltage drop across one of the resistors. So if I want to find the voltage drop across the 6 ohm resistor, I take the voltage change across both resistors, which is 12, times 6 over 6 plus 2. So that's 12 times 6 over 8, which is 9. So I have a change of 9 across the 6 ohm resistor. So if I have a change of 9 across the 6 ohm resistor, and I'm going from 6 to 18, would I add 9 to 6 or subtract 9 from 6? So this one is 6, this one is 18. In the middle, I got that the change, so I have V1 right here is 6, and V2 is 18, and maybe I'm just not asking the question the right way. I want to know what is the voltage right here, and I found that the change across this resistor was 9. So what is this V right here? It's 15. Because going from 6 to 18, I have to be going up. So I'll be adding 9 to get 15. So 15 volts. It's 15. Now, the 6 and the 18 were measured relative to ground, and I made ground the bottom branch. So that means this is also 15 relative to the bottom branch, so that's my answer. So 15 volts. Okay, questions on this one? So I will go look at the. Yay! And this time it's not my phone pen. Well, y'all hear when I was trying to use my phone pen and not figuring out why my